This video provides a brief overview of the concept generation and selection process that you will use in Mini Project 2. First, let's revisit where we are in the overall concept development process. In Mini Project 1, you collected information from your user in order to define your design challenge. You also started benchmarking different design solutions based on the criteria your user identified as important. In Mini Project 2, we explore how benchmarking and target specifications can help us to decompose our design into functions and then brainstorm and select concepts that achieve those functions. Once we complete that, we can actually prototype our functions and through testing make sure that they're performing within our specified target ranges. If they're not within range, we can change our design to make it better, and this will be the focus of Mini Project 3. But for now, let's focus on Mini Project 2. I'll go through the 6 steps in this video so that you can see from a high level how they fit together. The videos that follow this one will help you with the specifics of each step, and they contain much more information as well as many examples. So the first step of this process is benchmarking. This table should look familiar to you from working on Mini Project 1. It contains several examples of water purifiers. Benchmarking is the process of rating each design on each of your criteria. As you can see, for every criteria, you end up having a distribution of scores showing how your devices compare on that criteria. Again, this benchmarking table is for water purifiers. In Mini Project 1, you'll construct a similar table for cook stoves. After benchmarking comes setting your target specifications. Now, based on your criteria, there will be certain metrics that are important to you to meet. The example shown here is for a mountain bike suspension. And in this case, one thing you might be really interested in is whether the bike can descend fast. And that can be translated into a metric called minimum descent time on test track, as you can see here. At the same time, you might not know how fast your descent time should be, so you look at the time for a set of other designs. So here you have your concepts, and you have minimum descent time on test track, and you can see the times for each of the different concepts, and then you plot these times. And by plotting them, you can see better what the range of acceptable values are, and where you might like your design to fall. The target specification videos will cover this in more detail, but what you should know now is that your benchmarking and target specifications will come in handy during brainstorming. If you know you want your design to be fast or inexpensive or lightweight, it will help you to tailor your ideas to those things, and target specifications will also come into play later during prototyping and testing. Moving along, the next step is function decomposition, where you'll learn how to create a function hierarchy. Function hierarchy is the process through which you take a seemingly simple function, such as make coffee, and you break it into many sub-functions like so. Once you have those functions, you can move into concept generation by creating what's called a concept combination table. Here's a new example, a stapler. Already we have the main sub-functions of the stapler across the top, such as bind together. From there, we can generate all the different possibilities for achieving each function, and then create combinations of options to propose different design solutions. For example, this solution is made up of options 1, 2, 1, 2, and 1. So that is concept generation. In concept selection, we look for ways to cut our list of many concepts down to just a select few. There's a 2-step process to doing this: concept screening and concept scoring. Concept screening is where we put all of the concepts that we've generated into a table like this. This table shows different solutions for a splash guard on a vehicle. One concept is chosen as a datum or reference, in this case concept number 1, and the rest of the concepts are judged on whether they perform better than, worse than, or the same as the reference on each criterion. Plus signs indicate better than, minus signs worse than, and 0 is the same as. the total number of minus signs is subtracted from the total number of plus signs for each concept, and that becomes the concept rank. Many times there is a clear choice to move forward with, like concept number 3 here. But what happens if you end up with several concepts with the same high score? In that case, concept scoring can be helpful. In concept scoring, the concepts are assigned actual scores on each of the criteria, and the criteria themselves are usually weighted. The total score along the bottom is the sum of the weighted scores. In this example related to different kinds of medical syringes, one concept has a higher score than all of the others, and it's this concept that the design team would probably move forward on. The last step in this concept generation and selection process is prototyping and testing. At this step, you've identified 1 to 2 concepts that are worth developing further. Now you want to see if they sufficiently satisfy the target specifications that you set. And if they don't, you'll want to see if you can change or modify your designs so that they do. Mini Project 2 includes a brief introduction to prototyping and testing, and we'll explore this topic in more detail in Mini Project 3. So that is the concept generation and selection process. As I mentioned earlier, the videos that follow contain much more information about each of the steps you see here. Feel free to also ask us questions, and we look forward to seeing your designs.